Welcome to G4NAB TV. This video will hope to show the ease at which anyone can create a VHF or UHF node, simplex or duplex, using SvxLink. The software, developed by Tobias SM0SVX several years ago, has been in constant development, from its origins as a Linux version of EchoLink, to a fully integrated repeater and server control system in one package. Unlike other packages, such as All-Star and the Open Repeater project, which is an early version of SVXLink, this version of SvxLink is not an image, but a compilation, requiring just a little technical knowledge, but the instructions are very simple. As a compilation, it lends itself to updates that images are less able. Already questions have been asked as to why we need another network where others exist already. I have to respond that the UK amateurs have never seriously considered SVXLink, whereas elsewhere in Europe it is widely used. All that is required is a Raspberry Pi and a CM-108 USB sound card, the type with the chip visible topside. There are instructions on how to modify the sound card to control a transceiver, can be found at g4nab.co.uk. First of all, we have to write the operating system to the SD card. Whilst there are other apps that can do this, Raspberry Pi Image Writer has a special way to configure everything that you might need to make the optimum operating system. Click on the first button and select Other, then select the OS Lite 32-bit from the next menu. Select the inserted SD card from the second button. Next, click on the cog icon. You may be presented with a box that suggests using the Wi-Fi setting from your current machine, but select No for the moment, as we can add the Wi-Fi details in the upcoming menu. Click on the box to the left of Set Hostname, but leave the name as Raspberry Pi. Click in the box to enable SSH, and the circle to enable password authentication. Click on the box to set username and password, setting the username as Pi, and the password as Raspberry. You could change it, but would you remember it? Below you can configure your Wi-Fi settings, not forgetting your country settings. Finally, click on Save, then click on Write. It will take a while, and verify afterwards. I have already completed this stage. You will be advised that the SD card is ready for use. Our first task is to locate the IP address of the new Raspberry Pi on the network. I have used IP Scanner on the iMac that I'm running. Due to the activity, I am able to pinpoint the new Raspberry Pi at 192.168.1.156. So I am able to use this information when I log into the terminal to begin the compilation. To access the Raspberry Pi, there are several methods. For those familiar with PuTTY, I will leave you to make the connection. For those with macOS or Linux, the terminal is accessible from your operating system. For Windows users, type the Windows key with the key, and type into the box that appears, the word, command, and hit enter. For Chrome browser users, there is an SSH extension available. Our first command is as follows. Most commands will be in lowercase except where indicated. I shall type SSH space pi at 192.168.1.156-P22. You will type your own IP address. The -P is a port request and 22 is the default port for SSH. You will get to answer a question at first entry, so type Y for yes, and you will begin communicating with the Raspberry Pi. You will be prompted for your password. As you type it, it will be invisible, so be careful. You will arrive at your Raspberry Pi's terminal screen. For those who are used to Raspberry Pi software, you will not need to update or upgrade at this time. Our first step will be to add a piece of software called git, which we do with sudo apt install git-y. This may take a few moments, but this software gives us access to the GitHub and all the repositories stored there. Our next steps are a little more adventurous, but still easy to follow. Type sudo git clone https github.com/f5vmr/svxlink_raspberry. This installs all the parts we need to begin building SvxLink, including updating the OS, compiling the software, and most of the configuration. Before we run it, we have to make a small change to a couple of the files to make them run with our bash commands. Type sudo chmod +x svxlink_raspberry*.sh. We now run a major command. This command will firstly update and upgrade the operating system, then it will download the supplementary software required to build SvxLink. Finally, it will then change the settings for the sound card, installing changes for a modified CM-108 sound card if you have one. Answer yes at the appropriate place. As the software runs, there will come a point where you will be asked for the call sign of your new node. Watch for this. At the end of the compilation, which will take some time, the Raspberry will reboot. The screen display will be shortened during the compilation. This next command is sudo bash svxlink_raspberry/install.sh. We have now reached the point where the call sign is required. Either lower case or upper case. Please type it carefully. I am using G4NAB-2 here as G4NAB already exists. Once the call sign is entered, the compilation will begin. Again, I will shorten the sequence to a few minutes. At the end of the sequence, the Raspberry Pi will reboot, and we shall have to log in again. We need to log in again at this point, so we SSH pi at 192.168.1.156. You will use your own IP address, of course. We can leave the rest, as port 22 is the default. The first thing we need to do is to stop SVXLink from running, as it is probably in an error state, as not all the parameters have been established. We do this by sudo systemctl stop SVXLink. Now we first edit the gpio.conf file to ensure the parameters for the GPIO ports are correct. Sudo nano /etc /svxlink /gpio.conf. Some radios have differing voltage levels, so this will need to be explored. The Kenwood TK709 has active low on the COS, so this needs to be changed as an example. The GPIO ports and their corresponding pin numbers can be found on Google. We shall be attaching a wire to pin 16, GPIO port 23. In some cases you might need to consider using a simple transistor circuit to buffer the voltage. However, the maximum voltage level from the COS port of the TK709 is less than 3 volts, a safe level in this case. We save the file with Ctrl-O and enter and exit the editor with Ctrl-X. We must restart the GPIO service, so sudo systemctl restart svxlink_gpio_setup and enter. Now we need to edit the svxlink.conf. Type sudo nano /etc /svxlink /svxlink.conf and enter. The first task is to temporarily disable the module echo link. Scroll down to the simplex logic paragraph and line beginning modules. Move the caret over the comma immediately in front of module echo link and hit enter, then type a hash. You will see that the remainder of the line becomes a comment. Now scroll all the way down to location info and remove the hash from each of the 3 lines that you see. At the same time, edit your longitude and latitude in the 2 lines. Now save the file with Ctrl-O and enter, and exit the editor with Ctrl-X. Now we can proceed to a visual check if we have any errors. We can start SVXLink in direct mode, that will display any problem. We do this with sudo SVXLink. We have an error. This is not a problem, as some manual editing has taken place. To stop SVXLink in this mode, it's a Ctrl-C. Watch the screen for the error correction. That's okay now. The squelch is showing open, as there is no radio attached to the CM-108 sound card. The error shown now is due to the fact that the server hasn't yet given permission for the node to connect. All is correct now, and we can see the other connections. Now testing is complete, we need to set SvxLink running, so that it will start automatically whenever it boots. We simply type sudo systemctl restart SvxLink. If we still wanted to be sure that it was working, we can extend the command with a log tail as follows. Sudo systemctl restart SvxLink vertical bar tail -var/log/svxlink.log. And you can see that everything is working as it should, but is running behind the scenes. And there it is, connected to the server. And ready for the radio to be fitted. However, it is working. Watch the screen for a connection from G4NAB.
Here we go then.
Talk group 2350.
Connected to G4NAB-2. And to disconnect, it's DTMF910 hash.
Talk group 0.
Talk group 0 is the standalone talk group. G4NAB-2 will drop off the network after the expiry of 90 seconds currently, which is a period which is adjustable. You will also see M0XHN on 23526, which is the hubnet, which is in permanent connection with the SVX portal.
And here we have it. Once permissions have been granted to access the reflector, and the network password added to the svxlink.conf, the new node is now present on the SVX portal. You can see G4NAB-2 on the dashboard. To explain further, each node or repeater has passive access to the SVX reflector. This status is talk group 0. By transmitting to a node, using a DTMF sequence, 91235 hash, the node responds by reporting talk group 235. The next transmission to the node will activate all other stations that have the same talk group in their monitoring list. At the end of a session, you send DTMF 910 hash and the link is disconnected, and the home node reports talk group 0. There is a timeout period that can be adjusted. The list of talk groups can be changed or removed. Talk groups that are unlisted can also be opened, that two stations agree to use. There is also an auto QSY facility available too. In the next video, there will be instruction on setting up talk groups, echo link, and meta information. Apologies for the audio quality in parts of this broadcast, that has been due to a technical issue. This has been Libby on behalf of Chris G4NAB in Ashington, Northumberland. So, we have installed an operating system on an SD card, and installed it on a Raspberry Pi. We have installed scripts, using basic bash commands, updated the operating system, and downloaded more software packages, and a series of voice files. We have compiled a repeater control package, and edited it to run a simplex node. We have successfully tested it and installed it on a reflector, that will enable access to a wider network. What happens next is up to you, but if you need more information, then read about it on svxlink.org. If you need answers to questions, then please email Chris g4nab.ne63@gmail.com. Finally, full credit must go to Tobias Blomberg, SM0SVX, the author of the package, and to others who have contributed so much to the continuing development of SvxLink.